first, I'll be second, man.
Yeah.
Who's gonna hold it? Someone No, you're supposed to be holding it.
Wait,
The chair.
Let's work together, you guys. Don't worry.
everything's good?
Who's doing what?
The camera's good?
Where are my glasses? I'm gonna be
Blake, do you have my glasses?
Your right hand man.
I have my glasses.
Sunglasses.
getting through. Getting through.
Can I have my like glasses?
You can't
Where? Project?
Yeah.
It's on the left, you guys.
Is it check?
Let's not block the door.
Okay. You're blocking the desk up. Yeah. I can always for you.
Thank you very much. Answers. Questions. And there's some Lego candy.
Wow, that is so cool. Did you guys make this?
But we did play.
That is so wonderful.
This is a
Okay, with a couple of flyers about us.
Yeah. Flyers.
I don't have a free trip to Las Vegas in there for
Oh, that's very thoughtful, you guys. I love the Power Stackers logo. Well, good morning. My name is Tia. This is Ralph. We're both engineers. We work at NASA on the shuttle program. We work at the Air Force Research Lab. We are so excited that you guys are doing this. So whenever you're ready,
Hi.
go ahead.
We are from the Power Stackers Ophthalmology Research Center, or PORT. I'm Dr. Pedro.
Dr. Nana.
Dr. Justin.
Dr. Blake.
Dr. Eric.
Dr. Noah.
And I'm the patient, Gloria.
What is the problem, Gloria?
I have day blindness, so I wear sunglasses, even indoors, but not at night. I squint my eyes, and they sometimes shake because I'm very sensitive to light. And this is what I usually see, and this is what I see when I'm squinting.
This is what a person normally sees. Considering, I believe it must be a chromatopsia.
Are you sure, Dr. Nana? Because achromatopsia is a really rare eye disorder where the patient has no cone cells at all. Only 1 in 33,000 people in the U.S. have achromatopsia.
Oh yeah, my cousin in Florida has a chromatopsia too. He wears rain-tinted sunglasses to help filter out some light. He also uses larger font sizes to help him read. These improvements can only help ease the symptoms of a chromatopsia, but they do not cure it.
Remember when we visited Dr. Lau, an ophthalmologist, and Dr. Studebaker, an optometrist? They both said there is no solution to achromatopsia, but research is taking place around the world.
We did extensive research on achromatopsia from scientific journals, medical books, websites, and magazines. We also had a phone conference and a video conference with 2 bioengineers, Dr. Kakuza and Dr. Boson, on current research.
What help can I get now? Can you tell me more about the latest research?
There's gene therapy, bionic eye implants, and stem cell research. We are researching the bionic eye approach.
Let me explain. An image is projected upside down on the retina at the back of the eye. The retina is made up of 3 sensory neuron cells.
They are photoreceptor, bipolar, and ganglion cells. Photoreceptor cells are known as cone cells and rod cells. They have a diameter of 5 micrometers and 10 can fit in a single hair.
The photoreceptor cells convert light energy into electrical impulses. The electrical impulse is sent through the neuron cells and into the optic nerve at the back of the brain.
This is a cross-section picture of my retina. This here is a work of art. This is a cross-section picture of Gloria's retina. This is where the cone cells should be, but they're not.
A bionic eye implant, a product of current research, replaces the defective cone cells in the photoreceptor area. This is a model of a current bionic eye implant. It contains 1,500 photodiodes within the area of a pencil eraser.
There's
the
about
the photodiodes convert light energy into electrical impulses that are simply carried.
There's about 200 cone cells in a photodiode. Since there's a number of cone cells in a photodiode, the resolution of an image will decrease. The image will be more pixelized.
It's good that I'll be able to see, but everything will be blurry, and there won't be any details.
Don't worry, Gloria, for we've been working on an innovative solution to solve this problem. It is called the HDE, the High Definition Eye.
Based on past FLL seasons, we learned about nanotechnology. We can improve the bionic eye implant with something very small, a carbon nanotube. Carbon nanotube is 10 nanometers in diameter, can replace photodiodes in an implant.
Due to the unique electrical, mechanical, and physical properties of the carbon nanotube, they can be modified into different applications. For our innovative solution, we will develop a carbon nanotube to function like a photodiode or a cone cell. We call this nanocones. This will be part of the HDE implanted into the retina.
Even though 40 photodiodes is the same size as the tip of a pencil, we can easily fit over 500,000 nanotubes into each photodiode. Likewise, we can replace each cone cell with 500 nanotubes. Because there will be more nanotubes per cone cell, the resolution will increase. The image the patient will see will have more detail than a human eye.
So I'll be able to see better than the normal person with the implant? Can I have the HDE surgery now?
Well, this solution is still in the research state. Maybe in 10 years the research will improve and the cost will go down.
By that time, our innovative solution should help cure other retina-related blindnesses, such as macular degeneration, retinal pigmentosa, and even glaucoma.
10
years later.
Patient, okay?
Oh, because I haven't compared it yet. 3-year mark.
Now wait for the price to go down.
Is it? 10 years.
That's time.
Well, we're pretty close to that.
You're pretty fitted?
Yeah. I think we can finish
Let's
up.
finish up our
Wait,
work.
sure.
Congratulations, Gloria. You have the first HDE implant in the world. How do you feel?
Wow, I can see all the colors in the rainbow thanks to HDE. Wait, you guys look awfully young to be surgeons.
It's the glasses.
I can see clearly now, the cones are here.
See all the colors in my way. Gone are the dark clouds that had me blind. It's gonna be a bright, 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 sunshiny day.
That was just too wonderful. My goodness, I am so impressed. I love this. And is that Lego jewelry you're wearing?
Yes.
Right,
She
down
loves
to the
Legos
detail.
more than
Of course I
Legos.
do, because I love
She loves
Legos.
Legos.
That was just so awesome, you guys. How long did it take you to put this together?
Well, we started the season and we decided what topic we wanted to do, and we voted on it, and we all researched a topic, and we decided on this, and then we decided how we were going to present it. It just fell together.
Is this a current solution? Somebody actually looking at using carbon nanotubes, or?
Right now, carbon nanotubes are extremely expensive, but
Right.
they're still being used. And right now, there's no one doing this specific solution. They're doing artificial retinas and
Using
gene
the
therapy.
photodiodes?
Yeah, photodiodes and all this other stuff. But
We found a.
This is a picture of the nano cones, or
The carbon nanotube.
the carbon nanotubes that's actually, that's a ton of them, because when he holds up this big blown up picture, I didn't realize they were that small, because,
They look big.
Yeah.
They look very big when you see them all blown up and everything.
Yeah.
Yeah.
But they're
It sounds like you guys studied carbon nanotubes in the past, FLL.
Yes.
How long have you guys been attending that?
6 years.
Yeah.
Well,
But not all of us are.
We
Right,
varied
because-
because, like, it's,
Yeah,
our
these
first
three joined
year.
this year.
and they've been in it much longer.
Yeah, she's
My
been in it
second
2 years, this is my 3rd year, and this is their.
This is my 6th year.
Wow. You're the girl. So let me ask you a little bit about carbon nanotubes. Are there other solutions that people are using with carbon nanotubes? And do you think you could actually get it in 10 years? What do you think would be the
Well,
challenge?
right now, carbon nanotubes are like a couple million. They have figured out how to grow neurons on them so you can connect with nerves. So I think that in the future, I think 10 years is enough so we can figure out how to use them for electrical, to pass through electrical.
We can also, we learned this, that we can also dope the carbon nanotubes. So after that, it can work for us, like what Blake said, the mechanical and physical properties of them. We can use them to, like, we can imitate a neuron cell, so then it can work.
Were there other solutions besides the carbon nanotubes that you looked at?
There are no complete solutions right now to chromatopsia, but there are 2 other blindnesses like it, but they just haven't worked
Yeah.
But
on.
for you guys, did you?
Yeah, we looked at like stem cells, gene therapy, but we decided that this was a probably more immediate solution.
Okay.
New and never been
Looked at.
A little innovative there, huh? I have another question. It sounds like you guys talked to a lot of people, you've read a lot of journals, you went on the web, and it definitely sounds like you did the research that researchers do. Of all of those resources, if you had to do your project over again, which ones did you find most valuable if you could only pick a few resources?
1 or 2.
Because certainly you're surrounded by information these days. Which ones were best?
I found when we Skyped with the 2 bioengineers, I thought that was really good because we were able to hear like what's going on directly from the source. These are people that were studying things like this at the time, and they were able to give us more information on everything.
Yeah, one of them was even working on something that would do the same thing that we're doing, except it was a little bit bigger, and they were using photodiodes, and one of them was in a scientific manner.
Did you guys present this to anybody? Present your solution? If so, how was it received?
We presented it to one of the places, the engineers, but one of the things we presented to the SCC, which is the Sightless Children's Club, and so we presented to them, and actually, which is really rare, we found a father of 2 achromatopsia children, which is extremely rare.
Only in Dayton.
Yeah.
Only
So,
one today.
but they liked the project a lot because they thought that their children would be able to see in the future.
Cool. I have one more
Yeah.
question. I'm
And-
sorry.
It's okay.
Go ahead.
Yeah, and
No,
also
you go ahead.
we also gave them our resources that we found to them, so then they can look at it.
Wonderful.
You have 1 more question. Then we get to the delivery.
Did you change anything after you shared because you got a lot of information and then you shared it? Did you change anything you did based on their response?
Well, we just organized it more so it could be more well-received and more easily brought in because it was kind of complicated for some people, and we just did it so it was easier to understand.
Wow. Did you guys have fun doing it?
Yeah.
Yes. We had so much fun
But
watching
you learned a
this.
lot too, because it sounds to me like you really got a lot of information.
Yeah,
out of
you
it.
guys really did a great job. Thank you so much. And
Thank
wow, love the prop.
You're good.
Thank you.
And I love that. FLL Fun Lego first. Do
That's
the
good.
work. That
Terrific.
is just
Do
too
the work.
awesome.
Just got it.
You guys get a team photo.
Thank you.
so much.
Thank you.
Can we get a photo with the judges?
Thank you.
Can we get a photo with the
You
judges?
too.
Thanks. You're just
Thank you very
awesome.
Can we get a photo too with the judges?
I
you.
love that.
Thank you very much.
Great job.
We get a photo with the judges.
That'd be awesome. Do we have the time? Sure.
Yeah.
Spare. You want to carry it around?
Go get Pikachu.
Oh, I get Pikachu.
Okay.
You want to join us?
Awesome.
Ooh, that'll go.